Hey everybody, this is Larry, this is me going with Q3 of the bi-weekly contest 157, number of ways to assign edge weights 1. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this one. So this one I honestly misread a little bit, but there are two ways to do it mostly, and we will go over the two ways. The second way is an optimization that is important for Q4, but not important for Q3. I mean, maybe it's fine, but yeah. The core idea is this: it's going to be dynamic programming, and there are a couple of ways you could do it with dynamic programming. For the first way, the idea here is that okay, you have n nodes. You can only enter a node in two different states, right? Odd and even from the root. And as long as you do that, then you just kind of sum up all the count and make sure that you go to the correct node, and that's it. You could set it up in a number of ways, but that's the way I would think about it. It is kind of at this point, I don't know if I want to say standard, but it is a very common dynamic programming thing of just like summing up all the counts, right? So I'm not going to go over that DP part too much. My code here is a little bit more on the messy side, but we'll go over it now, right? First, I converted to an adjacency list. I do not like one index, so I convert them to 0 index. And then here I do DP. Well, there are two things. One is that I do the max depth, right? And once I have the max depth, and this is a regular DFS, right? Because it's just the number. You have a tree. What is the max depth of a tree? DFS, right? So D and DFS, and here we even keep track of the nodes that are in the max depth. Though it turns out you don't need to for this problem, but I kind of misread it a little bit as the number of paths to all the max depth nodes combined. It was not right, by the way. So it's fine. But yeah, but that's basically the idea, and we'll do some optimization from this afterwards. Anyway, once we get the max depth, which we used in a non-local way, maybe we could get this to return. I think that's fine too. I do dynamic programming via kind of a BFS idea, but it is in its core dynamic programming. The idea here is that okay, you start at so count of I don't know ij, where is I is equal to 0 if even, 1 if odd, and then j is just the node, right? So yeah, so basically there's one way to start at the root node, being even, and then for each of this, and you have node parity parent, so we don't go back to the parent. But yeah, but then now we just do delta 1 or 2, right? So we add 1, add 2, which is what the problem tells you to for edge weights, and then we get the new parity, which is the delta plus parity mod 2. And yeah, if we haven't visited yet, then we set the count is equal to this count, very standard dynamic programming part, this part ish. But also make sure that we do process that in the future. Otherwise, if we already done it, keep in mind that this is a tree, so everything is going to be in one direction. So there's no cycle. Yeah. That means that we visit the node again. That means that this is the you could say I don't know. For in dynamic programming sense, a transition to the graph, right? Or dependency, however you want to think about it. So you just add that to the current value, make sure you mod it, but you don't queue it again so that you don't double count. And that's it, right? So that's all there is. And then at the end, you take one of the max node. I had a for loop and it was wrong, which, because that's not the problem is that you only need one node. So that I take one of the max nodes, and then I take the odd parity, get the count, make sure we mod, and we're Gucci. And that's it. I think this is the dynamic programming formulation, right? And it's not so bad. I think the one thing that, and if you watch the live portion, you'll see me kind of get into this. And I honestly, at that time, and if you watch the really end of the video, I actually kind of go over it, but the same way that I'm going to go over here. So don't worry, you're not missing anything, even if you don't watch the end of the live video. But I couldn't figure about, something was bugging me, and I was like, wait, one is that I don't think this matters in the sense that I think only max depth matter, right? And part of that intuition is because, well, they kind of tell you, right? In the sense that all the nodes will give you the same answer. So I feel like that is a little bit of a hint in that all the nodes will give you the same answer. So I was like, oh, maybe then it is something. But then I kind of YOLO submit a power of 2, and then this is what I end up with. I just took the max step. I go, okay, max step minus 2, a power of 2, and then make sure that we remember the mod, and that's it. Yeah, and we can even clean this up a little bit more. We don't need max nodes. Right? So yeah. Oops, how did that happen? And the question is, you may ask, and you should ask if you don't understand it, why does this work? Well, actually, it's not that. It took me like a couple of minutes to realize what's going on. But for me, it was a pure YOLO submit. It was a pure intuition. And also, honestly, if you watch the live portion, it was bugging me enough that after submitting Q3, even though I probably should have been working on Q4, and I didn't at this point realize that they were the same problem, like a harder version of the same problem, I was like, okay, I think this is it. And it only took me an extra minute or two, right? Actually, we can play. Yeah. It only took like 1 or 2 minutes to just verify, right? And I had a typo, so that's why there's a wrong answer or one-time error. But you could see that I only did an extra minute, so I was like, okay, I think I could test this in a minute, so why not, right? But honestly, I did not know for sure that it was correct. But why is it correct, you may ask? Oh, I was showing the screen, but okay, whatever, right? I was showing that, sorry, I guess I covered it. It's not that important. What I said out loud anyway, which is that this only took 1 more minute to do. So I was like, okay, let me verify that this worked. And why does this work? Well, the reason why this works is actually pretty, right? And keeping in mind that the way that I think about a lot of these things is through visualization. And that's how I'm able to visualize a lot, able to kind of figure these out. And for this one, there's a very... For some reason, at the time, a lot of this is instinct / intuition, and a lot of this intuition is just built through years of repetition, right? So it's just a lot of studying, a lot of practice that I'm able to do this. There's nothing like, I don't know, right? But the idea here is that I relate this is with Pascal's triangle. So here you have some like, because in essence, let's say we have the max depth of length m. We go, okay, so it has to be 1, 2, 1, 1, 2, something like that, right? And the way that you kind of think of it that way, then, and it has to be m of them, and it has to be odd, is that, well, you can also think about this, like I hint at, as a Pascal's triangle. So what does that mean? That means that from here, you could say this is the root node, well, then it could, the distance, so you're given a m path to take, and you gotta take either 1 or the 2, right? And then same thing on the next level, right? You could take 1 or the 2 or the 1 or the 2, right? And then the same thing on the next level, right? You could take 1, which is the left, and then 2 is the right. 1, oh, drew that one weird. 1, 2, 1, right? And yeah, maybe I'll do one more layer, right? Just going left and right, left, right, left, right, left, right, left, right, right. So you go, oh. I did mess something up here. That's why I was a little confused. Okay, so this is a 1 and this is a 2, right? Okay. Right? And this is Pascal's triangle. So you know that the sum, so there are 2 things that you should know about Pascal's triangle at least, right? So like here is, this is like just something that looks like this, right? This is the sum of the previous row, if you will, right? And a lot of you might know this. If not, probably study it up a little bit. Then the other property is that this is some 2 to the n, right? And you could just do the math. This is 16, I think, right? So for each row, it's going to be 2 to the n, right? Okay, so how does this help us? Well, so then the proof is actually kind of easy. I'm just going to rewrite this a little bit cleaner. The proof is actually not that bad, right? Because, okay, so what is this problem asking for? You need an odd number of 1s at the end. And here, you can think about it as just, maybe you could even ignore the 2s, but it just means going to the left odd number of times, right? Odd number of 1s, odd number of times, right? So then now maybe you could go like and there is this like parity thing. For example, here, it's gonna be 3 ones. You cannot go left again because then that'll make it 4, and it goes here, right? And then, but of course, every time it goes right, that means that you have to go left in the future. So something like that. Anyway, though, what you notice is that, well, and this is true for here, right? Is that we will want every other number, right, in the Pascal's triangle, because this is going to be odd number of this is going to be even number of ones, odd, even, odd, even, right? And of course, if you kind of look at it this way, then now it becomes clear, right, that that because you take every other number, this is just going to be 2 to the n over 2. For your sake, you should also probably try to do it for odd number, but I think the odd number is actually, or odd number of rows, and the odd number of rows is even more obvious, right? Because you have odd number of rows like the next one, maybe change the color real quick, maybe like 1 5, what is it, 1 5 10 10 5 1, right? Something like that. Maybe I'm off by 1, but yeah, 1 5 10 5 1, right? And as a result of that, well, every other number is even more clear because then now they just cancel out, right? So half of that is even more true. So basically, that's the reason why from this visualization is proof that this is why this works. And that's it. That's all I have for this one. Let me know what you think. Complexity. I mean, this is just a depth first search. Well, I said I cleaned this up, but I lied because I still have this thing. You don't even need that anymore. So it just becomes this, right? Let me run it real quick and submit it real quick just to make sure. Yeah. And as you can see, this is just a depth first search. So this is all of linear time, linear space, and that's it. That's all I have for this one. Let me know what you think. Thanks for watching, and you could watch me solve it live during the contest next. Okay. Actually, surprised is a little way, to be honest. How am I doing on time? I usually check up to 2 people did 5 minutes. Okay. I could, I don't know. I could see people doing fast, but 5 minutes is a little bit quick for me. But I'm also like this. That was a bad one for me as well, to be frank. But like I probably should have gone down in 5 minutes faster. Okay, mod. There's a graph, tree, edges. All edges have weight 0. You must assign each weight 1 or 2. The cost of a path is the weight. Okay, so like any one node at the maximum depth, return the number of weights assigned such that its total cost is odd. So like any one node, is it rooted? Rooted at 1. Okay, so it's one index rooted at 1. Okay. Find edge weights is in the path from 1 to x. Any one node x. Ignore all edges not in the path. Okay, fine. But so you have something like this. Do we select 4 and 5? It's a really worded problem, but is there a tree thing? The star graph is always what I'm thinking about. Okay. What is the hot part? Okay, there's more stuff. Okay, so star graph, does that mess up? No, right? Because it's not DP on a thing. Though it is kind of. No, because you could do BFS. Okay, fine. Okay, fine. Yeah, okay, fine. person. I do stuff in one index. Or not one index. Okay, so then now we want to root at 1, so let's just go yeah, Q. Node 0 even, right? Node odd, right? Oh, the number of ways. Okay, so we have to be a little bit careful. I guess that's why I wanted to do it the other way. I forgot it's the number of ways and not whatever, but this should be fine. Yeah. Okay, and now for the node if right? Okay, so if count of if this is none, then count of MP is equal to count of no parity. We should set and then q dot append np vnp. Else we already did it, and that's fine. We have to not go up. We have to not go up. I think technically they didn't say anything about symbol paths, but for now we'll assume it's symbol. No, okay. That should be good, right? And then it's not just the leaves, it's the maximum depth. That's kind of annoying, but okay, fine. Okay, fine. Yeah, just write it. What am I writing?
Okay, go 0, -1, 0. Well, let's go at 1, doesn't matter. Did I do it the other way? I will just go out bounce. Alright, let's see. Oh, this is 1 and 3, 4 is 3, 4, right? Yep, okay. I think we're right. Or at least on the max depth part. Where are we getting 146? This is node parity? Why? Oh. How do I keep getting it wrong? Okay, that's fine. What we want is I probably need to mod this actually. I mean, I probably didn't need to, but what do we want again? Odd? One and 4. Okay, that's not quite right. Is it just one node at max step? I guess that the answer is always going to be true because at the max step there's only edges. Maybe it's even a power of 2 thing, honestly, and I just kind of did all this code for no reason. But yeah, okay, let's see. I mean, yeah, all we need is just right. Alright, YOLO submit. It times out, that'd be sad. That's accepted, but I do want to upsolve this. Maybe I should upsolve it afterwards, but I just want to see real quick. Okay, so this, right, so now we have max step. So we return max step. Something like that. Oops. Max step is going to be, oh no, because I did a +1, so just for that reason, so it's going to be 2, so it's going to be -2, I think, for the number of edges. Why does that take so long? Okay, let's give it a quick submit. I forgot to mod. Okay, well, I mean, but that's fine because like this is upsolving, right? I thought I should upsolve afterwards though, but nonetheless. Yeah, okay, here. Wow, that's a big graph actually. Yeah, I thought so. I mean, only after I did like crazy amount of things. All right, let's do Q4 now that we upsolved it. Apparently a lot of people probably did it just not dumb way. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Yeah, stay good, stay healthy to good mental health. I'll see y'all later. Take care. Bye-bye.